Assalamualaikum and hi, my name is Muhammad Zuhairi bin Zulkifli from Group 4 and also my teammate Nur Zulaika binti Muhammad Jasrim, Zairah binti Abu Zaki and Nur Amira Natasha binti Zairul. Okay, today I will present question 1. If we look at to this circuit is represent high pass filter, which is C and R is equal to 1. To solve this circuit, firstly we use import dialog command that user can input value of 1 that represent for R and input 2 that represent of C. So and then B is equal to R plus 0 and A equal to R plus 1 over C. This is represent for VR over Vin equal to R over R plus 1 over C. And lastly, we use frec command that represent frequency response. And then we can run. First, we input 1 for resistor value, also 1 for capacitor value. So this is the result. We can compare to this frequency response for high pass filter. The result is same.
My name is Nur Amira Natasha binti Zairul. My metric number is 2054. I will explain about question 2. Based on question B and question 2 is R is 10, C is 0.01 and B and A is formula for high pass filter because based on figure 1 is high pass filter. So for long space is for row vector y logarithmal space between decades. So for formula for F is formula frequency, for FC is formula for cut off frequency. For Mag is formula for magnitude, phase and formula for phase. To find the phase. For plot, we plot the magnitude response and we plot the cut off frequency. While we put the text to show the value of cut off. And for space response also we do the same with magnitude response. For subplot is we create the axis title position. So from subplot 211 means plot is put like this. Have a 2 graph and 1 is mean 1 in first graph. And while 212 is have a 2 graph and put in. So from text we label the cutoff. For magnitude response is over here, and the second phase response, the cutoff is over here. That's.
Assalamualaikum and selamat sejahtera. My name is Nur Zulaika binti Muhammad Jasrim and my matrix number is CE200129 and my friends
Zaira binti Abu Zaki. My matrix number is CE2K51.
Today, me and Zahira will present for the questions number 3 and number 4 for the project numerical programming. So the answer for the questions 3 is the type of filter in figure 2 is passive filter. And for the answer for questions 4, based on the figure 1 and 2, we design a RC bandpass filter circuit, which is we have 3 sine wave, 1 block at 2 scopes, 2 spectrum analyzers, and 1 bandpass filter. We reconnect all of them and we can see the output on the screen, which is spectrum analyzer, scope, spectrum analyzer 1, and scope 1. So this is the output for figure 1 and figure 2. So I will pass to my friends.
Next is I have to analyze the frequency resonance and bandwidth for the question number 4, which is it combines the figure 1 and figure 2 circuit, so it become the RC band pass. So we know that in figure 1, the value for R1 and C1 is 1, while in figure 2, they don't give you the value for R2 and C2. So I put my R2 is 10 and C2 is 0.01. So next is the FL. FL is the formula for the low pass frequency, while the FH here is the formula for the high pass frequency. So next is frequency resonance. This is the formula which is square root R. R is frequency low times frequency high. I simplify it like this so that it's easier for me. Next is bandwidth. The formula is you have to minus the frequency high with the frequency low. Next is subplot. We have two subplot here, which is this is the graph that will be shown in the display. So the subplot 211 and 212 means that for 211 is bandpass. So bandpass have to be the first graph, and the 212 means the phase response will be the graph below of the bandpass filter. So W here means the value for the y-axis. G1 is the low pass filter. I use the formula in J times W. So same here, W for the y-axis value. So G2 is high pass filter, formula in J times W. So to get G, you have to multiple G2 and G1. So this is the graph for the band pass. So the text function here, I want to display the value for frequency response and bandwidth. Okay, next is phase 1. This is the formula that I use. So this is the graph for the phase response. Thank you. That's all for group 4.